You're here behind me, and you will.
Hi, can folks hear me all right?
Yeah, you're audible.
Cool. Just give everyone about 10 minutes. Oh, sorry, 3 minutes, 4 minutes, and then we can start.
Yeah, that's the thing. Let's give people a couple of minutes and we can start.
Also, may I request everyone to mute themselves if you're not talking, but of course, feel free to, you know, unmute yourself and shout out a question if you have one anytime during the micro training. May I again request anyone who's not talking to please mute themselves for the duration that they're not talking, but obviously feel free to unmute yourself and shout out any questions or comments that you might have, just so that it's nice and clear for everyone. All right, so we'll give everyone else some time to join in, but in the meantime, let's begin. Hi, my name is Dhairya Gandhi. I'm a data scientist at Julia Computing, and we'll just go through this micro training really quickly, and we'll speak about why we're here, what we're trying to do, and how it's relevant, essentially. But before that, there's just a bit of, a bit about ourselves that I would like to share with you all. And simply put, with Julia Computing, this company was basically found by the creators of the Julia language. Hopefully, people here are relatively familiar or have heard of Julia and have used Julia in different capacities for their day-to-day. And the reason that this company exists is because as Julia's popularity grew in many different industries, there was a greater and greater demand that the founders saw essentially for having more enterprise use cases covered, especially in terms of things like having a robust training pipeline, robust indemnity support, things of that nature, corporate governance. and for that reason, they came up with Julia Computing. This was also a way to make sure that they could harbor as many interesting workflows with Julia as they can produce. And so for that, not only has Julia Computing worked on a lot of products, as you can see here, Julia Show for support, Team for governance, and Run for deployment and scalability at large scale. They have also been very integral in coming up with a lot of different packages that you may be familiar with. Some of them we'll use today. So, and not only that, things like coming up with a very robust IDE, for example, in Julia Pro, and introducing Julia to the masses through Julia Academy. More so, if you guys are interested, you can for sure go visit some of the case studies that Julia Computing has participated in prior times. These things are updated fairly regularly, and one of the really cool ones that has come out recently is optimizing bus routes in the Boston school area. So this is some students who came up with a simple problem. Buses don't run in the right schedules. It's really not efficient, but they found that they could make the bus routes in the Boston school area a lot more efficient, and they did that using Julia. And these were researchers at MIT. The interesting thing is that Julia itself was something that came out of MIT or has been worked on at MIT very, very heavily. But this research group had nothing to do with it. It just goes to show how the world is both a very big and small place at the same time. So this is a little bit about the company. Feel free to look at some of the case studies. There's some fairly interesting ones in there. One of them I showed you right there about bus routes. There's others about everything between machine learning and electrical grids, machine learning and electrical grids, finding out animal passage patterns, things of that nature. Also, of course, Julia Computing has been involved with many industries in the past. So as you can see, work on finance, machine learning, on parallel computing, on life sciences, energy, things of that nature. So I would highly recommend you guys go through the website and try to see what all areas Julia Computing has essentially worked on and has expertise in. Okay, so welcome to the micro training. And this one's fairly short. And the reason for that is we basically want to introduce you guys to problem statement, show you how it's done, and then open the stage for some questions. So there's a bit more understanding and some interaction that you guys can expect. So the topic for today is we want to put our trained machine learning pipeline essentially behind a web server and serve it. So for that, we have some questions. This is our introduction. Basically, some of the objectives that we have. This is our introduction. We go through how these things actually figure out together. So the motivation behind this essentially comes down to, why would you want a machine learning pipeline behind any sort of web server? Aren't they really, really complicated to build? And the reason is both simple and complicated at the same time, as you may assume. And I would try to talk about it. The simple answer is that we want to productionize the machine learning models that we've built essentially. There is so much work that has gone into it, and it's only sensible that we want to, put it out in the world where there's user-facing applications, especially, right? And one of the biggest advantages of doing that, of course, is you can get a really, really strong reproducibility story behind your products. Also, it means that you can scale it up fairly cheaply. And it means, as we'll see, that it can be done fairly simply. So we're going to build a simple web app today. That's our objective. And in that web app, we'll show how you can, first of all, train a machine learning pipeline. Second, make it available to a lot of people. And third, designing a sort of an environment where people can actually interact with it. Now, I'm sure people are fairly familiar with how web servers and the whole shebang works essentially. So the idea is that we'll be putting it all behind, some sort of reverse proxy and Nginx or something of that nature, where You can go the whole microservices architecture route where you have different routers who are pointing at different servers that take care of very specific capabilities. And this is just one of those chunks that we're dealing with right here. But through Dashboards.jl, which is what we will be using, I want to basically show how it can be done in a scalable yet simple fashion. Also, just to give folks some clarity, we're going to be doing a demo, and this demo I'm running on my local system. It's a fairly simple Mac Pro, but so it's not very powerful. So the training, I will stop the training midway, the training of the machine learning model, that is, just so that we don't waste too much time on that. But of course, we have a machine learning model that we trained prior. And since our objective right now is to learn about how the whole web server part of it takes place, we'll keep the machine learning part fairly short. So this is some of the motivation and importance of why we want to do this. We want to scale it up. We want to make these things available. And now we want to get into the general pipelines, right? This is essentially the meat and potatoes of the whole situation. Also, another short note, the code for this, the environments, everything will be made available to you after the training. So all of this you can access after this training. Unfortunately, the usual way we try to go about this is that people can actually follow along with code that they have with them at the time. But a web server is something that might be a bit more challenging to set up for everyone, considering that there's differences in platforms and whatnot that we deal with. So with that, let's get into the code. And as you can see, I have annotated the code here with a lot of text, and that's for good reason. It's so that you can follow along, you can see what is happening at every step. Um, so just sort of a show of hands, how many people are familiar with both a machine learning pipeline and somewhat how a web stack works, just so I get some sort of an idea about how familiar are people with these things.
Sorry.
So the question is basically um, just like raise your hands if you have experience both with a web stack as well as machine learning. So we get a fairly good idea of, just get to know you and me. Okay, cool. So it seems like everyone has some sort of experience more towards one side than the other. But this is the good thing, right? Like we want to make sure that you know how to do the simple thing easily, essentially. So we don't really waste any of our time and resources doing things that there is someone else who can probably do it better. So what we will do in this case is we will use Flux to train a machine learning model that we will train on the MNIST dataset. It's just a bunch of handwritten digits that we want to make sure um, that a computer can recognize. It's not really a very complicated problem, but the idea is that we want to keep it simple so that we can demonstrate more towards what it is that we're trying to showcase here, which is um, the machine learning, the web stack of it. Yeah. So great. So this is essentially very close to the kind of situation that one would find when they're training a machine learning model. This is an adapted version from Flux is Model Zoo. So from right here, I would really suggest and recommend people who have not visited the Model Zoo to do so. It's where we have a lot of our, simple demonstrative models ready for people to use and adapt to their own use cases. So as you see, the kind of workflow that we have going here is very similar to what you would generally expect folks to run. And of course, there's a bunch of optimizations that we can have on top of this. This is for demonstration purposes, right? So yeah. So, okay, we'll start with just importing the packages that we are interested in. So the important thing here is that we're going to be using the BSON library, whose concept is basically we want to serialize both our models and the trained weights, which basically represent how well it has learned in a separate file, which we can transport from one uh, place to the other. So you can expect it to be behind a sort of a service that runs up at will whenever you need it at the scale that you need it. It could be on an edge, however, and in that time we don't really have to deal with knowing anything about the machine learning. Essentially, we can decouple it. So all we really have to worry about is that we have these files, these BSON files, these serialized files, and that we can read them and we can store them in one place, read them in another. That way we can basically go for an entirely reproducible model as well as a reproducible web stack. So you're going to read in your images, you're going to make the batches, you can break it up into different batches as train test sets, train and test sets, you'll divide them. We have a very simplistic model here, nothing very special about it. It's good enough for our purposes for this training. And as you can see, we can of course run it behind the GPU as well if our machine does support that. One of the really, really amazing things about Julia is that it gives us the power to make sure that not only can we do what we want out of it, but also do it elegantly and simply. So if you need your models to run and train on a GPU because that's easier, that's faster, that's more performant, you don't really have to rewrite the whole world, which is sometimes the case with more complicated models and other libraries. That's one of our design goals essentially. And then here we have our complicated looking but fairly simple training loop. So we're going to go through 100 epochs essentially. And in those epochs, we're going to train our model, the parameters of the model based on the cross entropy loss. And as you can see, we have cases for early stopping in case we're good with the accuracy that we're getting. And of course, anytime we see improvements in our model, we want to save that, right? Because we're doing that every time. So this is a fairly simple case of how you would expect a normal training loop to look like essentially. Not in global scope for sure, but in general, this is the structure that it would follow in an optimized situation as well. So I already have this in this file called train.jl, and all I really have to do in this case is include it. As I said and alluded to before, we're not going to be training the entire model because that would take a lot of time and resources of my poor laptop here. But what we will do is see, assuming now that we have a fully, completely trained machine learning model, how do you actually make it available online? So let's give it a couple minutes. And in the meantime, let's talk about the other side of it, the dashboards.jl. I'm not sure if folks have tried using dashboards.jl. I would certainly encourage you to, especially people who have little experience with the web stack side of it. You can basically see how it translates to a completely purely Julia code base, but one that can do a lot more complicated things than we're used to. And for people who are familiar with, creating your own REST APIs and such, how you can simplify that whole pipeline with using something like dashboards where you don't really have to write any JavaScript. You don't even have to worry about REST APIs that you would generally have. So our idea, our goal essentially is that if I give you an image or a URL of an image, I want to be able to learn what that image says. So in this case, I want to say, if I give you an image, can you tell me if it's a 0 or a 1 or a 2, and so on. So that's going to be our goal here. And yeah, so this is going to take a little bit of time, but oh yeah, as we can see, our little model is being trained. We found our new best accuracy. Of course, this will happen a few times before it's completely trained, but we're going to stop this before that. In the meantime, if anyone has questions, I'd be happy to answer that. All right, so for now, I'll assume that the model is trained well enough. Just interrupting that so we can get rid of that. And now we have a trained model, okay? And within our Dashboards.jl environment, let me bring up Dashboards.jl. So this is basically a Julia port of the Plotly Dash project, which is also aimed at creating heavy duty and analytics intensive web apps, right? Because famous for its give me a second. Right. Can folks still hear me? Great. Okay, yeah. Is BSIN a generally good format to use while serializing trained models? Yeah, fairly. So there is some question of what kind of formats that we're interested in, and BSIN can save a lot more generic formats than that Flux users are using very often these days. And in that case, BSON works fairly well. Of course, if you have different kinds of models that don't say, for example, do much of differentiable programming, things like HDF5 and HDFS can also work very well for you in those cases as well. But BSON is something that we generally recommend folks to use. And within our dashboards module, let's start with just loading our models, right? So we have saved the models that we have been running, as well as the parameters, the weights, and we're just going to make sure that we have those in tow with us. So this is going to be helpful to actually serve, right? And for folks who are used to looking at these things, these are called style sheets. So this is CSS. Essentially, we're going to be using the foundation package, which provides some abstraction, some CSS libraries, which make it easier for us to style and reason about our interface. And as you can see, while we can pass, we basically want to create an app. And this app is just a skeletal structure. It is just a structure of what we want to show. It doesn't necessarily have everything in it yet, and we're going to be filling it up as we move on. So as you can see, I've given it a title. It's called Micro Training App. We have given it all the style sheets that we could ask for, and an assets folder where we're going to store all of our assets. I would recommend that folks trying this out go and look at some of the documentation and understand essentially how all of these things are laid out. So for example, you may be used to a div in HTML, and here we just have an HTML div and an HTML h1 function, essentially. And it creates closures which hold different kinds of values which dashboards can reason about, and will make it so that things look like we expect them to. And because it's Julia, it means that we can have our things like style just expect arbitrary name tuples, right? So that way we can write custom CSS if we so wished, but at the same time, it's easy for us to use things like classes, what have you as this keyword arguments. And if you were to notice, you would notice that the structure of our program looks very familiar to an HTML file. Essentially, we have div tags, and within this do block, we are using it essentially as a div block, right? The do block essentially works as a div block for us. And in that case, we're able to write a simple input field, which will take us, which accepts texts, which will take us to the parts of the images that we're finally going to be interested in. So spoiler alert, the images are not very pretty. They're part of the MNIST data set, so you can expect them to look like handwritten digits. All right. So another thing that we would have otherwise done with a traditional endpoint is writing callbacks, right? In which case we not only have, so the callback function can be used both to do an actual real callback as well as implement APIs on top of it. So you can see a bit how the generic nature of this whole business works. And notice how we're not writing any JavaScript. So essentially, we're going to be creating a callback on our app. And as you can notice, we have the image path ID. And when we see the value of that image path change, we're going to be manipulating the children of our image path div. Hopefully that makes sense. And this gives us the value that we are interested in. So of course, there's going to be a bit of, housekeeping. So in case we don't have an image, or we have an image that we can't reason about, is not a valid image. It can happen in many cases. So here, the easiest case that I could think of was when it's completely empty. But of course, there's going to be other cases, right, where you want to make sure that you can validate your inputs essentially. And in that case, here I'm just going to show a random image, so you have something to look at. It's pretty, right? And then, as you can see, we are going to be handling both local paths as well as URLs. So that way, it's easy for us to take multiple kinds of inputs and still be fairly confident that our pipelines are able to handle them just fine. And this is essentially where some of the more machine learning-y part comes in. Notice how we've had to do a little bit of image loading and then reshaping. That's only to make sure that we can send it across to our trained ML pipeline. So it can actually accept those images and then produce some meaningful outputs. And another interesting thing that I wanted to point out was, this is something that people have written completely new services for, and that is, well, when you're running a web server, especially when you're running something which is ephemeral, so in case of a microarchitecture, for example, microservices architecture, you cannot live without logs. Logs are something that are very, very important. And in this case, I'm trying to show that our logs can be composed with existing Julia functionality. So for example, things like logging extras and the logging module from base can be used directly to to reason about logs in a same fashion. And since it's just Julia, we don't really have to worry about how those operations are passed in, and it's fairly familiar for all that we're doing. So in our case, we're just going to be logging to the console. Of course, in a real environment, you're going to be logging to files and to S3 buckets, things of that nature. But so once we basically have the image that we want to work with, our next step is twofold. We're very close to an actual demo here, by the way. So this is something exciting, right? And in this case, still notice how all the code is very, very familiar. And if you were to remove all the annotations that I have, all the text that I've written for, just going about this whole session, you will notice that it's not only very Julian, but also able to mimic HTML when it needs to. So you don't need a lot of experience, and you can still use your existing knowledge base to come up with something which is useful but also easy to deploy. So as a matter of fact, my background is that of a data scientist, as I said earlier. So I have more experience with machine learning than I do with web design. But at the same time, you'll be able to see soon that the results are not too bad. And that's fairly that's a big shout out to the dashboards team who've made it easy for users to actually create uh, these web apps without much issue. All right, so the next thing that we're going to want to do is, once the user has given us our image, our output to them is going to be the image itself, so we can verify, as well as a graph, essentially a bar graph, which shows us the relative probability of what number that image actually holds, right? And does, that's ultimately our goal. We want to see the result, as it were. And since Dash is built on top of Plotly, the plotting that we will be doing on the backend is going to be with Plotly. Of course, you can mix and match, but that will require a bit more than simply writing something like a figure, right? And a graph that we're so used to from a Plotly graph. The final thing is we make our handler. The handler is somewhat the secret sauce in that it will. Yeah, go on. Okay, so let me continue here. So making a graph is just, so to show an image, we can basically just do an HTML underscore image, and the source is just the input value that we got from the user, right? That's what we're interested in. One thing to note, of course, is that the input value we assume is relative to the assets folder, but that is something that we can obviously choose and pick how we want it. That's just the default. And this is what we're going with today. So, all right, so to make a graph is also very simple. We just really need to give the graph function a keyword argument of a figure, and that figure in itself is a simple name tuple, and that name tuple in our case contains data, and that data itself contains all the data that we want to plot. In our case, it's just one data point, but just to hammer the point home, I have another name tuple here that you can have, just if you wanted multiple things that you're plotting, and as the complexity grows, so will the graph, right? And the handler, as I said, is what we will use to excuse me, the handler is what we will use to make sure all the REST APIs that we're interested in are handled for us. Of course, if you wanted more granular control, that is of course available. We can choose and deal with post requests, get requests the way we want to. However, excuse me, however, this is just one way to show, to do the easy thing, as it were. And finally, we will use HTTP and we will serve it on the 8080 port. Cool. Well, if that sounds simple, let us go and see what we have produced so far. All right. Oh, oopsie. I, of course, have to, I do have to start my server. And with that done, let's restart our app. And as you can see, we have a normal looking HTML page. It says, say hello to Dashboards.jl, which is of course what we're using. And it gives us a nice image to look at until we, of course, add a path that we're interested in. So just to get as I alluded to before, I already have some images that I have saved prior. These are all on my local system, by the way. I've just saved all of the some of the digits from the test set of my MNIST. These are just the random indices for those images. So all it really is waiting for at this point is for us to give it an image path. So let's try and do that. At the minute I send across this, and voila, what you see is we were able to take user input, we were able to manipulate what needed to happen. As you saw, we saw our image, which is what we wanted to do. And we also see a beautiful plot of the relative probabilities. And of course, as we see, our model is able to identify this image holds a 3, right? So we can try a few more here, just to make sure that our model is performing exactly like we expect it to. And oh yeah, that's a 2. That is in fact a 2. And all of this is completely interactive. So if you so wish, you can select parts of it. If, of course, you wanted to show how this whole business works, you can zoom in, and it gives you very, very high accuracy, which is good. You can take screenshots, and that snapshot is, of course, valid. You can just double click to zoom out, all of that good stuff. And as you can see, it's also showing you the very, very tiny relative probabilities of this image being anything but a 2. As we see, it's fairly sure. So yeah, that was the demonstration that we wanted to show you guys today. And if there is anything, and if there's anything that you guys would have questions about, I would be happy to answer them now. All right, so the question is, do I need things like very heavy dependencies like Node? And the answer to that is found very simply if you just go inside dashboards and we look at all of the dependencies that it has, and we see that, of course, it does not depend on very heavy things. Of course, it depends on Plotly, because that's kind of its bread and butter at the end of the day. But everything else, JSON, Git, macro tools is fairly self-explanatory, some data structures in HTTP. So you don't really have many heavy dependencies. Right, so that should answer your question. The web server itself is written in HTTP. There is very, very simple dependencies out here, of course, with Plotly taking lion's share of the weight. So the templating engines are interesting, right? So because everyone has their own, they come and they are very specifically designed for some particular use cases. And the answer is you choose depending on what kind of application you're running. So in this case, as we saw, it's really, really easy for me to develop my HTML code directly in Julia, and I don't really have to write any HTML, any JavaScript, or for that matter, any templating, because I can just use my Julia variables there, right? But of course, if you wanted to use Jinja, you're absolutely welcome to. So I'm going to give folks a couple minutes if you have any other questions. If not, that's going to be essentially how we plan these things, right? Like we want them to be short and sweet and to the point. And our point here was to A, train a simple CNN, and B, put it behind a web server, and C, make it available so anyone can basically use it. All right. I think with that, we have good coverage of what we wanted to show. Do check out our website, as I said earlier, as I alluded to earlier. And I hope you all have good evening and good day. Thank you. So that's going to be our training for today.